Hey, one more liquid change. That's galvanised nails in cola. Still fizzes like mad. It was flat when I poured it out, but that's fresh. Now, if I was doing this with a university budget, if I could just, wander in and borrow the entire biology department, that would be great. What I would do to do this properly would be get exactly 1 litre of distilled water rather than just dehumidifier water. Water from a granite stream, maybe above Gaping Gill on Ingleborough Hill. Water rich in limestone, maybe below Melham Cove. Actual seawater, and of course cola. Maybe also salted cola, but nobody mentioned salted cola. Who the hell's salt cola? Exactly 1 litre of each. Keep them all agitated, keep them all at a standard temperature. Keep stirring them around. Big machine will do that for you for 168 hours. And then they have a wonderful thing called a chromatograph? Spectrometer. Sorry. Or spectroscope. They do spectroscopy anyway. Now, I don't know whether it's a white light source and a prism you can rotate, or it's one heck of a radio emitter that you can tune. But there's a dial on it which you can turn to select a wavelength, and it shines that wavelength through a little square hole. And they have little square quartz containers. Yes, quartz. 2 rough sides you do touch and 2 clear sides you don't. And you put it in so the light beam shines through the clear sides, and then you can use distilled water and say 1 millimolar, 3 millimolar, 10 millimolar, 30 millimolar, 50 millimolar, 0.1 molar, 0.3 molar, 0.5 molar and 1 molar iron chloride. Good choice. To see how much of the light gets absorbed by that concentration of iron. You choose a wavelength that's absorbed by iron but not by sodium, chlorine, calcium, aluminium, or anything else that's going to be getting involved, or phosphorus, or glucose, or whatever else is in this ghastly liquid. And choose a wavelength that's absorbed by iron. You can then measure exactly the concentration of iron in your bath of whatever liquid and say exactly how much has been dissolved, which is much more precision than I'm going to offer. One thing I can do, despite this being kitchen counter science, is show you what I got out when I just changed the liquids just now. This is just from the steel pins. That was the almost distilled water from the dehumidifier. See all this stuff? This is black powder that was in it. Black as in iron 2 oxide. This one was tap water. Red. Rust brown. The colour of iron 3 oxide. So they're both corroded. There's quite a lot of iron in each case, but apparently it's more oxidised in tap water. This one was salty tap water. Sort of between the two in colour. Seems to be less of it. Of course, tipping it out into a handful of this stuff isn't exactly scientific, but there doesn't seem to be as much of it. Possible explanation for that is that with the amount of salt already dissolved in the water, there just wasn't room for it to dissolve anything else. Sodium is more reactive than iron, so if it's saturated with sodium, it won't dissolve iron. Well, much. And this one was the cola. Notice anything? No sediment at all. Doesn't mean that the iron wasn't dissolving in it. It's just no sediment. So if it was dissolving, it was dissolving and staying dissolved, rather than the nails falling apart down there. I won't know which until later. I thought it was interesting that there's no sediment in the cola.